Graphing systems of equations. Two equations form a system of equations. The ordered pair that is a solution of both equations is the solution of the system. Okay, the ordered pair, where it says that it's a solution of the system, that just means where they cross. Yes.
I got a question.
I'm just kidding. Not really. A system of two linear equations can have one solution, an infinite number of solutions, or no solution. So the system, the answer, there's three possible answers: one solution, an infinite number of solutions, or no solution. If a system has at least one solution, it is considered consistent. Okay, write these down. Consistent, remember the definition said consistent if it has at least one solution. Okay, it's independent if it only has one solution. So this first graph where they cross at one point, okay, it's consistent because it has at least one solution. It's independent because it only has one solution. All right, so when they just cross paths like this, it doesn't. This one's perpendicular, but it doesn't have to be. Okay, it's consistent and independent. If the two graphs are the same line, okay, they're consistent because they have at least one point. Okay, that's the same. They're dependent, okay, because it has an infinite number of solutions. They're the same line. Inconsistent, they do not cross, okay, because they have no solution. So it's not consistent, okay? Any questions?
Nope.
For inconsistent lines, do they have to be parallel?
Yes.
Yes. Yes, they do. If they were not parallel, would they cross somewhere?
They'd be consistent.
They would be consistent and independent. Okay? Write this down. This is what the questions on homework will look like. It'll say use the graph to determine whether each system is consistent or inconsistent, and if it's independent or dependent. So what it does is it gives you a graph like this. There are 4 lines on here. Okay. This is y equals x minus 5. Okay. That's a 5 right there. There are 4 lines there. It'll pick 2 of them. It'll say these are the 2 lines it wants you to look at and see if they're inconsistent or consistent, or if it's independent and dependent. Okay? So I look at negative 2x plus 3. This is this line. I look at x minus 5, which is this line. Okay.
Consistent and dependent. No.
It is consistent because will these lines eventually cross? Yes. So it is consistent. Since it only has one point, it has exactly one solution. Is this independent or dependent? It's independent. So if they cross at one point, they are consistent and independent. Hush. All right, let's go with this. Let's go y equals negative 2x minus 5 and y equals negative 2x plus 3. So let's go with those lines. This is negative 2x minus 5. This is the negative 2x right here. Okay? Because this is plus 3 right here. Since they're parallel, they're inconsistent, right?
Yeah.
All right. Write this down. Okay. This is the other type of question you're going to see. It says graph each system and determine the number of solution it has. If it has one solution, you're supposed to name it. That means name the point where they cross. So first thing we do is graph this. So y equals negative 3x plus 10. My y-intercept is going to be at 10. My slope is negative 3, so I go down 3 over 1. Okay, I have enough. I can draw this line. This is x minus 2, so our y-intercept's at negative 2. We go up 1 over 1 every time.
Whoa.
Alright, so there's my 2 lines.
Let's go with consistent.
Oh, dude.
This is consistent and independent, right?
Yeah.
And it wants you to name the solution. So name where it crosses. Where does it cross at?
3, 2.
3-1.
I can't see that far.
Okay, that's okay. The solution is at 3-1. That's where they cross. Any questions? Here's your assignment.